Stop. Section 8.1, factoring polynomials completing the square. Well guys, I'm pretty sure that you already know all these formulas and you know how to do all this stuff. So I'm considering this as a review section. So I'm going to quickly go over special products. The formulas you're supposed to remember from like somewhere from school. Maybe some people learned them in college. So there are 7 special products which you will need to remember. Product number 1 is a minus b multiplied by a plus b. And you remember that it's supposed to be equal a squared minus b squared. It's called difference of squares. Product number 2 is a plus b squared. And you know that to open this one, it's a squared plus 2ab plus b squared. Number 3, the very same one, but was minus. And that's a squared minus 2ab plus b squared, right? Number 4 is going to be x minus a, x squared plus ax plus a squared. This is a special product which looks exactly or similar to the sum of 2 terms squared, but instead of 2 we don't have 2 here. It's going to result into difference of cubes. So it's going to be x cubed minus a cubed. A similar product was plus over here and the minus over here is going to result in a sum of cubes. So the sign between x and a is going to be similar to this one, to the first one. If minus here, plus here, plus here. This sign is opposite to this one. You see plus here, minus here, plus. 6, a plus b cube, and that's binomial, right? That's a cube plus 3a squared b plus 3ab squared plus b cubed. 7, a plus b, a minus b cubed. That's very similar, but it's going to have alternation of minuses. Well, for this one, guys, the coefficients are 1, 3, 3, 1, right? And the powers are going down for a and going up for b, like 3, 2, 1, 0 for a, right? And for b, 0, 1, 2, 3. Same over here, alternation of signs because we do have minus. So that's 7 special products. For me, let's say, you will need to remember these 3. Other 4 is good to know, but we're not going to use them in this class. Maybe for future, you start memorizing them. How do we use these products? We use them for factoring. Now, I'm going to erase all of them because I don't have any space to do any examples from these rules. So let me erase all of them. And we use them to do factoring. I'm going to consider several examples of factoring, not all of them, but some important ones. We're going to start with factoring out a common factor. For example, these 2 terms have common factor of 2, which you can take outside of parentheses. So here, if you take 2 outside, you're going to have x's left over. Here, if you have 2 and take it outside, you are going to have left over of 1 actually, not 0, right? So we factor out 2, common factor. Sometimes common factor is not a number. Sometimes it's connected to x or it's a variable or unknown. So here common factor is x and common factor is x. So I'm going to factor it out from here, and that's going to give me x left, right? There are 2 x's, x by x. I take 1, and that's just x left. Here, if I take x, I'm going to have minus 2 left. So we factored out x. Well, let's do one more. X cubed plus 3x squared. Here, common factor is x squared. Usually, x is also common factor here, but x squared is highest common factor here, right? So I'm going to take x squared outside of parentheses. So here, because there are 3 x's, I'm taking 2 outside, I'm going to keep at 1. Here, I'm taking 2 x's outside, I'm going to keep just a number 3. Okay? Number 4, a little bit more complicated case when you have 4 terms. X cubed minus 4x squared plus 2x minus 8. Here I'm going to do factoring in pairs and then kind of factor it one more time. So for the first pair, common factor is x squared. For the second pair, common factor is 4, right? So I'm going to factor out x squared from here and 4 from here, not 4, 2, sorry. and 2 from here. So x squared is going to leave me x here instead of cube, minus 4 here, right? If I factor out 2, I'm going to have x from here, and 2 out of 8 is going to give me 4. You see that again I got 2 terms with common factor, and this common factor is not a number or variable, it's actually 2 terms, it's a difference of 2 terms, right? So I'm going to factor out x minus 4 now. Left over from this term is x squared, left over from this term is 2. So now I did total factoring. Okay? What else? Well, I'll need to erase these 4 cases to continue. 3 more examples. Example number 5, x to the power of 4 minus 16. If you look at this one, you're going to recognize formula number 1. There is x squared minus 4 squared. Remember, formula number 1 is factoring this one into x squared minus 4, x squared plus 4. Let me remind you, formula number 1 was looking like this. A squared minus b squared equals a minus b, a plus b. So these are the difference of 2 squares, and the a minus b is x squared minus 4, x squared plus 4. I'm going to continue using this formula on my first parenthesis, and that's going to be x minus 2, right? Because 4, it's actually 2 squared, and x plus 2, and x squared plus 4. There is no formula for the sum of squares, so we can keep it as it is. Okay? So I factored my next example. So for next one, I'm going to factor sum of cubes. So for example, you have x cubed plus 27. How do we factor it? Okay? That's formula number 5, I think, from our list. So I have a cube of x, and 27 is actually cube of 3, right? So it's x plus 3. First parentheses are matching the sign. Then the square of the first term, product of the first and the second term, x multiplied by 3, and then the last term squared, right? That's 9. Now, this is plus. This one's supposed to be minus. The signs are kind of opposite. Okay? So I factor the sum of cubes. The last one, what I want to factor is the cube of some binomial. And I think, well, maybe I should erase name of the section and first example. Let me do it. Imagine somebody gives you a polynomial looking like this. Something like this. Well, it's probably not very easy to recognize, but it looks like it's x cubed, and this looks like it's 2 cubed. And you can probably recognize that this one is 2 multiplied by 3 by x squared, and this one is 3 multiplied by 2 squared by x. And you can recognize that this one rolls into x plus 2 cubed. Well, if you compare it to the formula, and that was formula number 6 in our list, we're going to see that's x cubed. Yes, that's x cubed. The next one is 3, 2 multiplied by x squared. Well, 3, 2, x squared. The next one is 3, x multiplied by 2 squared, and that's 3, 2 squared, and x. And the last one is 2 cubed. Okay? Okay, sorry, my board is moving a little bit. Now we are going to complete the square. Last thing in this section is how to complete the square. Let me erase this example. Well, what is complete the square? Complete the square is to bring your expression to one of the formulas, 2 or 3. For example, you have expression, let's label it, complete the square. Complete the square. So, for example, you have expression x squared minus 2x, and somebody wants you to complete the square here. Means that you actually want to have a trinomial instead of binomial, which rolls into a perfect square. Well, if you add over here 1 and subtract 1 to not change this expression, this trinomial is going to make a perfect square x minus 1 squared. If you look at formula number 3, it's a minus b, and that's a squared minus 2ab, and that's 2, and a is 1, and b is x, and 1, which is like b squared. Why do I do minus 1? I don't want to change expression, so I'm going to write down x minus 1 squared minus 1. So I completed the square, and I did not change my expression. Well, usually the question is how to figure out what do we add here and subtract here, or what do we need to add to complete the square. Well, let's kind of compare it with general formula and make a general rule, use it once on some example. So general formula, I'm going to use x plus a. General formula is going to look like this. X squared, plus 2ax plus a squared. So usually if you do have something like x squared plus 4x, the binomial, what was a actually? Well, you compare the number you have in front of x and 2a. You calculate that a equals 4 over 2, or the coefficient here divided over 2. So you can add this a squared over here. 4 over 2 is 2, so you add over here 2 squared, which is 4, and to not change it, you subtract it. Then this expression is going to make a perfect square, which is going to be x plus 2 squared, and this is just minus 4, which is like extra number left over. Okay? Well, I want you to complete 2 squares here, and that's going to be like a self-work. And guys, if you need more examples of completing the square, you can just pick up any question, like any binomial you can complete the square, any binomial with x squared. So, self-work problems. A, x squared plus 20x. And problem B, x squared plus 1 over 3x. So try these two problems by yourself for 5 minutes, and then I'm going to show you solutions. So I'm going to count to 5, and you can stop the video, and this is 2. Okay, 1, 2, 3, 4, 5. Okay, solutions. So x squared plus 20x, I know that this is kind of 2a, so my a from here equals 10. So I'll need to add here 10 squared, because that's a squared, right? And to not change it, I'm going to subtract it. What I'm going to have here, the perfect square is x plus a, which is 10, and minus this one is making up 100, right? Okay. Problem B, that was problem A. Problem B is going to be x squared plus 1 over 3x. Well, again, this number, it's actually 2a, from where we can find out that a equals 1 over 3 divided over 2, which is going to give us 1 over 6. So what I'll need to do, I'll need to add here 1 over 6 squared, because it's a squared. And to not change expression, I have to subtract it right away. Now, what is going to be my perfect square? These three terms are making a perfect square, x, and you're just supposed to add, if you have plus here, a, which is 1 over 6. And subtract this extra term, square. Okay, that's all. Okay, well, do the homework and practice more on completing the square. Completing the square is a useful skill. You will need to use it eventually in calculus somewhere, and finding, like working with circles, also helpful to know how to complete the square. Okay, thank you. That's all.